Good afternoon, everyone. So good to see you all in yet another interesting session on AI, and welcome to day 30 of AML Learnathon. And today we are going to discuss about explainable AI. So this topic is in a way is related to the other two topics that we discussed earlier this week. One is the post estimation by Ruben, and then the other one is MLOps. So I think you would be able to figure that out as we go through the slides. So without any ado, let me share my screen here. Um, all right, so explainable AI. Before jumping into other slides in this presentation, so let's have this question answered. So can anyone of you tell me what do you see in this image?
Wolf.
Husky is on the left side.
Good, excellent. So wolf and husky, excellent. So sir, could you also reason out or explain why did you say this as a husky?
Husky, I follow Husky activity closely, Deepan. I follow the particular dog very closely, so I know the familiarity of Husky.
Right. So based on the certain features of this dog, you'd be able to identify that this is a husky because of its pointed ears and almond-shaped eyes, and then double-layered fur and black and gray and white kind of color in nature. So because of these parameters, you're able to identify this as a husky, right? So what happens? So a couple of months back, people tried to feed this image into AI model, and the AI model recognized this image as a wolf. So the problem is that that is what called is called a black box, the AI model, or the people does not have enough understanding on what is happening inside the AI model, or the algorithm. Even the developer who created the algorithm, they themselves will not be able to explain you why the model has a decision that this is a wolf or a husky. In order to overcome this problem, so we have got plenty of solutions to a problem, and we have plenty of problems as well. So for this problem, so we have a solution called explainable AI. So so the black box, so as you could see in this image, in the first image, we feed the image to the ML model or AI model, and that runs algorithm to understand what that image contains, and then based on the pixel identification and some other factors, it is able to identify this as an insect, right? And if you try to understand the logic, or reasoning why it has resulted or decision that as an insect, you not be able to, or the AI model will not be able to give you any answers. In order to overcome that problem, so there is a solution called explainable AI, which using which we'll be able to reason out why the AI model has come to any conclusion, like why this and why not that, and why not something else like that. So it is the black box is commonly referred to an algorithm or model whose internal working are not visible to end users, or the one who is running the trying to run the ML model. And the problem, as I said, so let's say in the first case, the black box or the AI model is able to recognize this image as an insect, but how can you trust the accuracy of the prediction or the results? So this could be problematic, especially in the industries like healthcare or finance. So in the healthcare domain, if you want to deploy a AI model, then for disease diagnosis, you would have to input the people's or the patient's information, like their age and then their sex, and then the symptoms they go through, and all those stuffs, using which the AI model would be able to diagnose all the symptoms, and would give you whether the patient is suffering from so and so disease, right? So if the AI model is not able to reason out the explanation on why it has arrived at such a decision, then the doctors will not be able to arrive at a decision whether the whether should we trust the outcome of the AI model or should we not. So what if we can back up, or if the result is backed with some evidence, like why did the AI model come with so and so decisions? So that is how the AI model, explainable AI works, and especially in the industry of finance. Let's say that we want to prevent fraudulent transactions in the system. So if the system detects all the transactions as fraudulent, it's a problem, and if it detects any random transactions as fraudulent, then again it's a problem. So if it detects a particular transaction as a fraudulent, then it has to explain on the reasons why it has detected the transaction as a fraudulent transaction. So for this, people would have train the model with the various data, and the explainable AI system would help us to identify, on what factors the AI model had helped us to arrive at a particular decision. So let's say we are trying to take up a loan from a financial institution, and we submit a loan application form to the institution. And also when we submit the loan application, they would also collect various other informations like the credit history, and then your identity, and then your loan repayment history and all those stuff, right? So when you feed this information into AI model, so it will run its algorithm and arrive at a decision like whether the application can be approved or it can be rejected. So if it is rejected, then the institution is responsible to give the user an explanation on why they are not able to give them a credit sanction, right? And on the other case, if the systems approve all the loan applications, then the business owner would have a confusion whether should we trust this AI decisions, because it's end of the business and they'll have to put in all the money, right? So if the decision is denied or rejected, then if the person approaches the customer support, they would have to give justification to the applicant on what basis the application got rejected, as well as we need to have monitoring practices in place. As as Arun said yesterday, the data drift happens in AI model, meaning, so if you're running with if the model is trained on old data, and if you have a changes over the year and after year, then you would have to tune the model based on the latest data. That is what the data engineer and scientist would do to train the model. And then internal audit and regulators, so they would be identifying the decisions made by the AI model to understand whether the decisions are fair, whether is the loan rejection is fair, or can we do something to improve our AI model to grant the loan to the end customer. So these are the things can be addressed with the help of explainable AI. So again, these are the questions that you would get with the result of XAA. So why did the AI model do that or give the decision, and why did that not do that, and on what cases, use cases did that or do that succeed or fail? And if there is a error in the outcome, then how do we correct the error? So how can we train the model to be more accurate on its predictions? All these steps would go on to that XAA. So as I said, XAA, what is XAA? It is the ability of an AI system to explain its decision-making process. So on what grounds it is arriving at a decision, and to make AI systems more trustworthy and transparent. So especially in healthcare, so it is very important to have a trustworthy AI model in place so that we can give a quality treatment to the patients, and then providing users with an explanation of why a particular decision was made. So, and to increase the transparency and accountability of AI systems. So basically we have these three techniques to arrive at the decision, or to have transparency on the decisions. So the first thing is the prediction accuracy. So prediction accuracy is something like you would be running simulations of in the AI model, and compare the XAA output with your training data sets. So that way you'll be able to figure out the accuracy of the AI model prediction. And LIME is the most common tool used for prediction accuracy. It stands for local interpretable model agnostic explanation. And traceability. So traceability is a process of so when you try to search or feed the image to a AI model, so it tries to gather all the information from the model, right? Meaning, So the AI model is composed of neural network, and in the neural network you would have various neurons. So when the image is processed into pixels, it would try to gather all the neurons, and the traceability is something like, it would try to reference the it would try to compare that with the reference neuron, showing the traceability links and then the references, so that if it answers you with if you feed the AI model with the husky and you get wolf as the output, it would be able to tell you what are the on what cases, or what are the neurons that it had as a reference to arrive at that decision, and then decision understanding. So these two, the first two are addressing our technology requirements. The prediction accuracy and the traceability would address our technology requirements, and the decision understanding, something you can visualize the data, or you can even visualize the decision tree on what basis that the decision has arrived. So it is just a UI representation or a dashboard where you can look into the you know uh, data and explanations, and it can help you to understand on what grounds, or on what basis the decision has been arrived. So uh, traceability uses a common technique called a deep lift. So it stands for deep learning important features. So it would actually connect all the neurons that is more related to the search you are doing in the system, and that would be able to produce that result. So the idea of XA is that how can we increase the trust and be transparent with the AI model. So uh, most of the companies are using a black box model, meaning they are able to feed the input to the AI model and they get the output, but they don't know whether the output can be trusted for further purposes. So if we have the XA in place, then we can as we go, we can train if we have inaccurate outputs, then again we can train the model with more information, uh, and then we can run the simulation until we get the more accurate results. So with the help of XA, we'll be able to achieve that. So on the if we are not going deep into the Lyman deep lift implementations yet, so probably we can park that for the future discussions. So yeah, that's all about XAI and trusting your AI model. Thank you.